Okay, so for day 6, we're going to be talking about the intermediate value theorem. So this is going to be one of our first theorems that we're going to take a look at for this semester. So we're going to just write it out, and then I'll show you on a graph what it's going to mean. So the intermediate value theorem, which you can refer to as IVT, and you can use that abbreviation on the AP test. It says if f of x is continuous, on the interval from A to B, and those have brackets, so they're included, and f of A is less than y, which is less than f of B, or f of A is greater than y, which is greater than f of B. In other words, y is in the middle. Then there exists at least one value x equals c on the interval from A to B with parentheses, so A and B are not included, such that f of c is equal to y. So what in the world does that mean? So we're going to draw a graph. So on your graph, you're going to have the x value A, the x value B, because that's what tells you the interval we're looking at. And then I'm going to plot this point here and here, and I'm just going to draw a graph through here. Okay, so it said, one of the main things it said was it had to be continuous. So the graph has to be continuous on that interval. So it is continuous. And then we're talking about f of A and f of B. So if this is the point where I put A, then this would be your y value that goes with A, which is called f of A. And then if this is where your B value is, that y value would be f of B. So it says y has to be between f of A and f of B. That's what these two things mean. So if I put my y value anywhere in between here, so I'm going to put my y value here. It says then there exists at least one value x equals c such that f of c is equal to y. So this means if I come over here, since y would go at this point right here, so do you see how this would put c being in between A and B? So this is saying if you have a y value, as long as your function is continuous, if you have a y value between the y values of your A and B, then that means that c has to be in between A and B on the x-axis. So then we have x of c on this interval. Okay, so that's called the IVT, or intermediate value theorem. If you have a y value in between the two y values of f of A and f of B, then there has to be a c value that's in between A and B. Now, that's not going to be on A or B, it has to be in between A and B. So before we see how we're going to actually write these out, these are just some introduction examples. So for example 1 here, we're using this first graph. It says, is there a value of c, so an x value of c, on the interval from -5 to 2? So just so we know where we're looking from -5 to 2. Yeah, that's the only part of the graph we're looking at. So we're trying to figure out if there's a value of c such that f of c equals 2. So because they're telling you f of c equals 2, they're talking about this y value here. So here's the y value of 2. It's saying, do we have a point in between that where we actually have a y value of 2? Well, yes, we do. So the answer to this question would be yes. Okay, so it's just saying, is there a y value on our graph between these two with a y value of 2? Okay, then the second question said, does the IVT guarantee, so now we're talking about the IVT, guarantee a value of c such that f of c equals 2 on the interval y or y not. So the biggest things about IVT, the first biggest thing is it has to be continuous. Okay, so we saw this at the top, but this graph has to be continuous. Well, if we're looking from -5 to 2, there's a jump in the graph, so it's not continuous. So that means IVT is not going to work. So we're just going to write this out. We're going to say no, the IVT does not guarantee a value of c on our interval from -5 to 2, and that's because f of x is not continuous on this interval. So that's one of the biggest things we'll be checking for in a minute when we actually look at IVT, and what we have to check for is that it has to be continuous. Okay, so now we're going to look at the second graph over here. So this one says, same graph, but is there a value of c? Now we're just looking from -1 to +5. So we're looking from -1 to +5. So we're only looking at that part, such that f of c equals 2. So f of c equals 2 means that we have a y value of 2. Okay, so from here to here, here's the y value of 2. There's nowhere over here where there is a y value of 2. So this is no. We don't have anywhere on the graph from here to here where it is a y value of 2. Okay, but then it says, does the IVT guarantee that there would be a value of 2? So for IVT, from -1 to 5, it is continuous. So let's write that down. So it is continuous. But what's happening here is that this 2 doesn't fall in between our y values. So how we're going to indicate that? If I say f of -1, so in other words, this endpoint -1, the y value at -1, the y value at -1 here is -1/2. And then the other endpoint's at 5, so if I get the y value at 5, let's just say it keeps going here, it would be about -3.5. Okay, remember up here at the top when we wrote our intermediate value theorem, it said that our y value that they're asking us about, so in this case 2, has to be in between those two y values. Well, 2 is not between these. So it has to be continuous, but it also has to be between there, so that's also not true. So just to write out a statement here, we could say no, the IVT does not guarantee such a value of c on the interval from -1 to 5 because f of c equals 2 is not between f of -1 and f of 5. So in other words, it's not between those y values there.